In some scenarios, it is unclear which way friction points, and this is an example of one of those situations. So one reason why the friction might be pointing down the ramp is because the block lowercase m is trying to pull uppercase M up the ramp, so friction resists that. But the reason why friction might point up the ramp is that well, its own gravity, as well as the spring pulling on it, is trying to make it go down the ramp. So maybe friction is trying to resist that. So it's unclear which way it'll point just by looking at it. So we're going to have to do some pre-work here. So forces that I'll say influence M to slide down the ramp would be the spring force, and it's the x component of its own gravity. So the free body diagram for capital M would have tension pulling upwards. It'll have the spring pulling down. I know the spring's pulling on it because it says it's stretched, and springs want to return to their natural position. And it's got gravity straight down, but that will be split into two components. FGY, FGX. I will make down the ramp as my positive x direction, and I will make perpendicular to the ramp as my positive y direction. There's also going to be a normal force here, and that's going to be equal to the y component of gravity. And then what we don't know is friction. Should probably draw it in, but we actually don't know which way it's pointing right now. Okay, so how about the forces that influence M to slide up the ramp? So that would be tension. So basically, if we compare these sets of forces, if we can find out which one's bigger, that's going to be the way the block would go if there was no friction. And then friction would have to go in the opposite direction to keep this whole thing at rest. So the force of tension, that's actually going to be related to the other block. So the other block that's just hanging there, it's hanging by the same string. So if it's going to be at rest, then the force of tension is going to equal to mg of that block. The force of the spring is going to equal to k times x. And the x component of gravity is going to be mg sine of theta. Okay, so I can compare these things and see which one's bigger, and that'll tell me which way friction points. Okay, so let me just calculate some of these things. So I'll start with the spring, the magnitude, kx 500 times 2 centimeters needs to be converted to meters, so 0.02. So I believe that works out to be 10 newtons. So 10 newtons down the ramp because of the spring. Now I'll say FGX, the x component of gravity. So 2 kilograms, 9.8 sine of, uh-oh. Okay, so the question is missing some information here. So I'm going to give in the angle here, and I'll make it 60 degrees. Okay, so I'll calculate this now. So that's 17 newtons. And now going the other direction, tension, pulling it up the ramp. That's mg as we discussed, so 1 kilogram times 9.8, that's 9.8 newtons. Okay, so I think there's a clear winner here. The forces influencing the box down the ramp are bigger, so therefore friction must be aiming up the ramp to keep it at rest. Because that would be the negative x direction based on what I defined to be positive and negative. Okay, so B, I'll actually go ahead and try to calculate the coefficient of static friction here. So friction, the magnitude of friction, we know which way it points. What about the magnitude? Well, the magnitude basically has to balance out these forces to keep these things at rest. So it's going to be the 10 plus 17, take away that 9.8. Okay, so whatever that difference is going to be what's needed to make the forces balance. So that'd be 7.2 newtons. Now we're going to say that's equal to mu times normal, and hopefully isolate for the coefficient of friction. The normal force on the box is equal to the y component of gravity, which is mg cos theta. And I'll divide both sides by mg cos theta to come up with my value for the coefficient. Oh, it's capital M because it's the block that's on the ramp. So looks like that's just going to be 7.2 over 9.8. Because the 2 and the cos 60. Cos 60 is a half, so 2 times a half. They cancel each other out. Okay, so this is giving me a value of 0.73. So the coefficient of friction, of static friction, must be at least, it can be higher, but it's got to be at least 0.73 to keep this all at rest.